A rocket fired straight up is tracked by an observer on the ground 1 mile away. Show that when the angle of elevation is theta, the height of the rocket in feet is h equals 5,280 tangent of theta. Find the height of the rocket when theta is 20 degrees, 60 degrees, 80 degrees, and 85 degrees. We assume that this is the ground level and the rocket is fired up from the ground. Assuming that the observer is somewhere over here, the angle of elevation, meaning that he or she looks up to the rocket, and that angle is theta. This theta varies depending on how high the rocket is. At any point, we would have a different angle theta. Assuming that the height of the rocket is h, because that is the variable that we are asked to use in the problem. From the right triangle in the diagram, we see that if we were to label h at the height of the rocket, the horizontal distance from the observer to the rocket launch is 1 mile, but 1 mile is equivalent to 5,280 feet. And so, using the trigonometry of right triangle, we have tangent of theta equals opposite h over adjacent 5,280. Isolating h, we have h equals 5,280 times tangent of theta. This is what we need to show. We obtained the same formula that they asked us to show in the problem. For the second part, we simply need to evaluate this expression as variate theta. When theta is 20 degrees, the height is approximately 1,922 rounded to the nearest foot. When theta equals 60 degrees, the height is 5280 tangent of 60 degrees, which is approximately 9,145 feet. When theta is 80 degrees, the height is 5,280 tangent of 80 degrees, which is approximately 29,944 feet. And lastly, when theta equals 85 degrees, the height is approximately 60,351 feet. Make sure that our calculator is set in degrees mode.